Hello everyone and welcome back to my YouTube channel, Learning Swift with Tony. We will continue today with part 3 of building our weather app, which will be an iOS project written in Swift UI. It could very well be a take-home project for a junior iOS developer position. It is a simple project, but one that requires the understanding of many key concepts necessary for a position as a junior iOS developer. Concepts such as basic Swift UI layout, downloading data from the internet, decoding JSON data, saving and retrieving user data to and from the disk, and so on. In today's lesson, our focus will be on a function called flatMap that is available on the new result type. We have covered the new result type in part 2 of this series. Its flatMap function is a powerful function and it's worth taking some time to learn it and understand it well. In practice, we will use this new function to rewrite our JSON decoding function we created last time in order to make it much shorter, simpler, and most importantly, much more easier to read. Let's remember what the goal of this function was: to take a string representing a file name for a JSON file on the disk, somewhere in the app bundle, and find that file, load its content into memory, and then decode it into a custom data structure we wrote for this purpose called API response. As you recall, our decoding function was returning an optional API response. And this had to be optional because the file the function is asked to decode might not even exist, or it might not contain any valid data that can be converted to our own custom structure. So in those cases, the function will return nil, and we will have no information at the call site regarding the reason for that failure. Our new decoding function, however, let's call it getAPIResponseResult. We will add the word result in the function's name. We'll return this time a result type instead of an optional value. It will be, put in simple English, a result of an API response. And this result, being a result type, will either provide a valid API response as a success associated value if everything went well, or it will provide an error in case of failure, and that error object will contain information regarding the reason for the failure. Please take the time to watch first part 2 of this series in order to get a good grasp on what the new result type in Swift is all about. Alright, ready to get started? The decoding function we wrote last time had 3 distinct steps, and each of these steps could fail in one way or another. Step 1 was to locate the JSON file somewhere in the app bundle on the disk. And to accomplish this, we used a function called URL for resource with extension, which is part of a bundle object, including the main bundle object provided to us by the bundle class itself. This function takes in as an argument a string representing the name of the file and spits out an optional URL. This return type is not a URL, but rather an optional URL. And this means we could get a nil from this first step, in which case our own function, getAPIResponse, is done and it cannot continue to step 2. So it will be just returning nil and stop right here. We can do that. We can return nil from our own function because the return type of our own function is also an optional value. And if we do this, we will not give the caller any information about the reason for returning nil. Returning nil basically means the function failed for some reason, and yet we are not communicating the reason for the failure in any way. And that is one of the issues we want to fix by using a result type instead of an optional type as a return value. On the other hand, if everything went well and we got a valid URL from step 1, then we can continue to steps 2 and 3 and attempt to load the contents of the file into memory first, followed by decoding its content into our own custom structure. Step 2 was trying to load the contents of the file, since at this point in our code we do have a valid URL to work with. And for this task, we tried to use an initializer provided to us by the data class, which takes a valid URL as its argument and spits out a bag of data, basically a simple collection of bytes with no particular meaning, at least not yet. But I said it right the first time. We tried to do this, and success was not guaranteed. This initializer can throw an error, and we learned in the last video how we can deal with that possibility and catch that error when it happens. When an error is thrown, we catch it and just return nil again. And yes, we can print some error description in the console this time, but that will be just for us, the developer. The call site will never get this error description. If, on the other hand, loading the contents of the file went well, then we got a valid data object and we moved forward to step 3. Step 3 was the last step in the decoding process, and at this point we had a valid data object to work with. Here we used a new instance of a JSON decoder object, and we called on this object a function called decodefrom, which takes in a data object and spits out our own custom API response structure. But we had to use this try keyword again, because this function can also throw an error when things don't work well. So we had to write code for that case, catch the error and return nil once again. Same as in step 2, we could write an error description in the console for debugging purposes, but this will not be propagated to the call site. Finally, if everything went well in step 3, then and only then we got back a valid API response custom structure, and at this point we could return that structure and be done. Now, this was the function we developed last time, and we mentioned the disadvantages of doing it this way. Today, we will refactor this function and write a much shorter one, containing a single line of code. And we will do so with the help of the new result type in Swift 5 and a powerful flatMap function that can be applied on the result type. To differentiate a little bit from the function we wrote in the last video, the name of this function will be similar, but it will include the word result in its signature. If last time we used the name getAPIResponse for the function's name and it was returning an optional API response custom structure, this time the function's name will be getAPIResponseResult. And the return type of this new function will not be an optional API response any longer, but rather a nicely packed result of an API response. This way, the caller will either get a valid API response structure or an error, and it will be the caller's responsibility to decide what to do in each case. The number of steps will be the same. In step 1, we will start from a string representing a file name and locate that file somewhere in the main app bundle. We will write our own function to do this. Let's call it URL result for resource with extension. We will extend the bundle class to include this new function so that all bundle instances will have it, including the main bundle instance already provided by Apple, which we already used before. In case of failure, the caller will have information regarding the error that took place. In plain English, this is called a result of a URL. The error is always a possible part of a result enum, so it can be omitted when describing a result in English. Once we have this new small function on bundle instances, we can call it on the main bundle, so we can get our first result, result1, a result of a URL, by feeding the file name that got passed to us as an argument. In step 2, we will take result1, which is a result of a URL, and transform it somehow into a result of data. Last time we used an initializer for a data object that takes in the contents of a URL and produces a data object. But this initializer throws an error if the loading fails for some reason. We do not want error-throwing functions anymore. So this time we will write our own function. Let's call it result_contents_of. That will similarly take a URL and it will return a result of data. It will not be an initializer this time, of course, because an initializer can only produce an object of the type being initialized, or an optional version of it. Instead, our function will be a static function on the data type, and we will discuss what static means a little later. So once again, we will have a result being returned to us, meaning either a valid data object or an error containing the reason for failure, which is great. But we have a little problem here. This static function of ours takes a URL as its argument. However, what we have to work with at this point is result1, which is not a URL, but rather a result of a URL. So how can we feed a result of a URL to a function that takes a simple URL? Well, this is where the flatMap function comes into action. Flatmap is a function on results that basically maps or transforms a result into another result. FlatMap basically takes a transformation function as its argument. So it is a function that takes another function as argument. This is called functional programming. And if you are new to this concept, then stay with me a little longer to see and understand how cool this is. Let's remind ourselves what result really is. It is a simple enum with two possible cases, a success case or a failure case. These cases are mutually distinctive. You either have one case or the other. There's no way to have no case at all, and there's no way to have both cases at the same time. Now, when the initial result has a success case, it will take its associated value, in our case it will be a valid URL, and it will apply the transformation function to produce a new result with a new possible success or a new possible failure. On the other hand, when the initial result has a failure case, FlatMap will simply propagate that original failure as the return value without applying any transformation, therefore flattening the initial result. A few important tips to remember here. Functions that take other functions as arguments are part of something called functional programming. Even though Swift is not a pure functional programming language, there are many features of Swift that drive it more and more towards functional programming. And many foundation types in Swift, such as arrays, dictionaries, sets, and result, come with functional programming type functions, such as map and flatMap, just a few examples. Familiarize yourself with these functions before applying to a junior developer position. Alright, so how do we get to use this flatMap function in step 2? We start by applying flatMap on our result 1, which is a result obtained in step 1, a result of a URL. It will need a transformation function, so let's use the trailing syntax and prepare to write a closure as the argument to flatMap, which means open and close curly brackets and code in between. And this closure will take in a URL because result 1, when unwrapped, will provide a valid URL. So we can write URL in. Inside this closure, all we need to do is to have code that will return a new result. And this is where we call upon our data.resultContentsOf function we discussed earlier. The URL we feed into this function will be the one available as a local variable inside our closure. Now, similarly in step 3, we will transform our result 2 into yet another result, a result of an API response, which is our final custom structure containing the decoded data. Last time we used the function decode_from on a newly instantiated JSON decoder object, which takes a data object and converts it, if possible, into a custom structure, in our case, into API response. But the function can throw an error, and that is something we are avoiding now. So instead, this time we will write our own little function, decode_result_from, which will take in a data object, just like before, but it will return a new result, a result of an API structure. When we do have this function written, we can take our previous result 2 and apply on it a flatMap, just like we did in step 2, which means another closure in curly brackets, which this time comes with a data argument. And for the actual transformation, we will use our newly written function on the JSON decoder. Now, we do not have yet our function written, decode_result_from. But if we did, this last line of code where we call our JSON decoder function will generate a compiler error. And it will say that the compiler is not able to infer the type of our result 3. What is going on? Our first result, result 1, was inferred correctly without any issues, and so was result 2. Why is it that this third result, result 3, cannot be inferred by the compiler? The problem is our last function, decode_result_from, needs two pieces of information, but it only has one argument, the data object we need to decode from. The other piece of information is a generic type, an actual data type it needs to decode the data into, which in our case is API response. The only way we provide that information is to explicitly declare the type of our result 3. We cannot just expect the compiler to know what we need in this case. We do that with a colon after result3, followed by the type we want result3 to be in this case, a result of an API response, and then followed by assigning the result of flat mapping the previous result true. Are we done now already? Well, almost. We just need to return something, and that something is result3. We know we can return result3 because it has the same type that our own function is returning. It's a result of an API response. So we are A-OK. Now, this is indeed a lot shorter than our function in the last video, but it is not really a single line of code, is it? It is sequential now, which is so much better. We got step 1, followed by step 2, followed by step 3, and we return. That's great. No more spaghetti code all over the place. Much easier to read and understand. But how can we get this function even shorter and reduce it to a single line of code? For that, we need to learn about one of Swift's compiler abilities, the ability to infer type. We have actually already used type inference in our function, even though we might not have noticed. Our result1 has a type, since all properties need to have a type, but we didn't explicitly declare its type. We can if we want to, but for the compiler it is not necessary because it can infer its type from the function URL result for resource with extension, which returns a value of type result of a URL. Similarly, the type of result2 can be inferred by the compiler, and therefore we do not have to declare it explicitly. The compiler can infer that result2 will be a result of data, because our function result_contents_of returns a result of data. In the case of result3, however, we did not have the same advantage. Here we had to explicitly declare its type before assigning it as a value, and that is because the generic nature of our decode result function, which we call for a data object. It needs to know what is the final structure we want to decode that data into. However, in about 99% of the cases, Swift compiler is able to do type inference on its own, which is awesome. It saves so much typing and it makes the code much easier to read and understand. What else can we omit in our code for this function to make it even better? This last closure, in which we ask a JSON decoder object to decode our data, is right now an explicit closure because we explicitly name the data variable. But we can easily make this an anonymous closure and not name the variable at all. In which case, we cannot use the variable name anymore to pass it to decode result, but we can use the generic $0 variable name, which just means the first argument in the closure. In our case, it is the first and only argument in the closure, but some closures can have more than one argument. Similarly, in assigning a value for result2, we can delete the URL argument for the closure and instead use $0 to access the first argument, passing it to results_contents_of. Alright, what else can we do? Instead of saving result3 into a constant first and then returning from our function, we could just return its value directly, without a middleman result3. But what happened to our explicit declaration of results3's type? Remember, we had to explicitly declare the type last time. Do we still need that now? Nope, we do not need that any longer. Since this is a return statement, the compiler will be able to infer the type being returned by using the return type of the function. Swift type inference in action. Very sweet. Let's put the entire return statement in a single line of code now, which looks and reads much better. Here is even a better way to reduce code. We can get rid of this $0 argument altogether by replacing the entire closure, which means these curly brackets, with rounded parentheses, meaning replacing the closure with an argument, where the argument is simply the name of the function we want to use for the flat map transformation, in our case decode result. We do not provide an explicit closure to flatmap anymore, but rather simply the name of the function, and the compiler takes care of passing the right argument to that function for us. Pretty cool, isn't it? In the same way, we can get rid of the $0 argument for result2 and replace the closure provided to flatmap with an argument representing simply the name of the transformation function, in our case, result_contents_of. Do we still need to set aside result2 in a constant before returning it? No, not really. This flatmap call on result1 is actually result2, So we can skip saving it separately and instead chain another flat map on it directly, like this. Then we can simply return this whole chain. Why can we do this? Because result1 is a result type, and all results respond to the flatMap function. The return of this first flatMap call is another result, and that is why we can chain another flatMap call on it, making it a single line of code. Of course, we can go even further and chain this two-element existing chain to the very first call for the URL result for resource with extension. It will not fit on my screen, but you get the point. We can now return this three-element chain. Finally, we do have a single line of code in our function. And because there is a single line of code, Swift can once again infer the fact that this line of code is the return statement. So we can omit the return keyword also. Truly beautiful. Now let's finish up by formatting our code to look a little better and break apart our single line of code into 3 lines of text. It's perfectly fine. The compiler sees this as a single line of code, even though we have spread it out on 3 lines of text. And that means we do not have to add the return keyword back. Perfect. We now have our own function getAPIResponse from JSON file with a single line of code, using extensively the flatMap function applied on different results and taking advantage of the compiler's ability to infer the types of middleman arguments. Our code looks very good now, but we are not yet finished. This function, URL result for resource with extension, does not yet exist. We will have to create it later, and we will create it in such a way that it will exist on any bundle object, including the main bundle object provided by Apple. We will do that by extending the bundle class, and it will be an instance function. Similarly, the function result_contents_of does not exist yet either. We will create this one too. However, this one will not be an instance function, but rather a static function. And lastly, we will also have to create our third and final function, decoded, and this will be another instance function. But while creating these 3 functions, we will get to understand better some key concepts in programming. The difference between instance properties and functions and static properties and functions. Because you see, not all dots are created equal. What do I mean by that? This dot here follows a class name, the bundle class, which means what follows after the dot is either a static property or a static function, meaning something defined on the class itself and not on every instance of that class. And in our case, we have a static property, a property called main. The same goes for the dot after the data class name, which will be followed by a static function this time, our own function result_contents_of. It will not be a property, but rather a function. However, it will still be something static, defined on the class itself, not on the instance of that class. This dot now is different because it does not follow a class name, but rather an instance of an object. So what follows after the dot is an instance thing, either an instance property or an instance function. It will be our own function called URL result for resource with extension in this case. And the same goes for our last dot that comes after JSON decoder, which will be followed by our own instance function called decoded. So what is up with this empty rounded parenthesis following JSON decoder? That is called instantiation or initialization, and it simply means an instance object is being created from a type. Many objects can be created with no arguments at all, but we still need to add the parenthesis. That is an indication that we are calling the init function on a type, which is a special function that creates a new object of that type. This init special function can also take arguments like any normal function, in which case the parenthesis will not be empty. But parentheses that follow a type name always means instantiation, and it is equivalent to explicitly calling the init function. They have the same result, a new instance of a type. Come back next time and we will continue to work on our weather project by creating our missing functions. And one of those functions will require us to learn to create our own custom error. That's going to be interesting. Writing these small functions will give us a good grasp on the difference between instance properties or functions and static properties or functions, in addition to getting a clear picture of what instantiation really means. These are all key programming concepts every developer job applicant should know. I hope to see you all in the next video.